in today's class, I'll talk about the t-distribution. Now, recalling a little bit about the confidence interval, what we learned in the previous video was if the standard deviation of the population is given to you, then you're gonna first of all create the calculate the margin of error, and that you can calculate the margin of error by using the z distribution, and the formula to calculate the margin of error was z times sigma upon square root of n. And this formula, you can use it if the standard deviation of the population is given, or you can also use it if standard deviation of the sample, which is denoted by s, that is approximately equal to the standard deviation of population. If one of these two condition is given to you, only then you're going to use this. Now, what if our sample size is so small that we cannot assume that the standard deviation of the uh, population and the standard deviation of sample are same, and on top of that, this thing is also not given to me, the standard deviation of population. Only thing given to me is standard deviation of sample is given to me. Then in that scenario, I will move to the t-distribution. If I look into the formula for t-distribution to calculate the margin of error, it looks exactly the same as the previous formula. Only difference is z alpha over 2 is replaced with t alpha over 2, and sigma is replaced with s. And now we're going to use the new chart. This is the chart we're going to use. Rest everything gonna remain same. Again, when we are calculating the confidence interval either for z distribution or t distribution, we will always stick to the middle portion, middle 98, middle 95, middle 80, middle 99. So that's how we're gonna solve the question. So let's look into this table, how to locate the value in this table. Now, if the sample size is given to me, so let's say the sample size is only 20 given to me. In this uh, uh, in this distribution, we need to first of all calculate the degree of freedom. Degree of freedom is equal to n minus 1, and this formula is given to you on your formula booklet too. Now, how to calculate the degree of freedom for when the sample size is 20? So degree of freedom will become 19. And in the question, it is also given that I wanted to create a confidence interval of 95%. So 95%, as I said, confidence interval is always two tails, means it's always the middle portion. So this is the 95% two tail, and the value of degree of freedom is 19. So I'll look at the value correspond to that. This will be the t alpha over 2 value. So I'm going to go in this direction from top. I'm going to move in the downward direction. This is the value. I'm going to say t alpha over 2 is 2.093. Now, what if the values of degree of freedom are huge? Why I'm saying that? Because if you see some of the values, so as soon as you move after 30, the values in between values are not there, and if you go beyond 200, the values are not here. So I'll tell you the real reason for this one, because once you go above 200, 250, you will also find that the z and the t values are almost same. That's why those values are not given here. But how you gonna approach these kind of questions if the value is not given? Let's say you are given a sample size of 175. Okay, the n value is 175, and degree of freedom will become 174 in that scenario. So you're going to look at the value one prior to 174, which is given to you. So that is 150 given to you, and I'm assuming the confidence interval is still 95%. So I'm going to keep rolling it down from the 95%, go downward. So this is 95. One more time, keep going downward, and then from 150, I'll move it in forward direction. This is the value I'm going to take. Another example, let's say 99% confidence interval, and the value of n given to me is 300. So degree of freedom will become 299. Now in that scenario, I'll take the value of 200 here, because one prior to 299 which is given to me is 299% confidence interval. So this is the value, and I'm going to move it down here. So this is the value I'm going to consider. So hopefully you understand how to look into the t distribution table. Now, based on whatever we've learned, we're going to try and solve a question on the t distribution. So this is how the t distribution question going to look like. A radio producer measures uh, the duration of 52 randomly selected songs played on the radio station, no repeat workday playlist, and computes the sample mean duration of 4.27 minutes with the standard deviation of 1.12 minutes. Calculate the margin of error and construct a 95% confidence interval for the population mean duration of the songs on the station, no repeat workday playlist. All right. So what is given to me? We are given a sample size 50 randomly selected songs. So n is 52. And no repeated workday computers means mean duration is 4.27 minutes. So X bar is 4.27 minutes. And with the standard deviation, well, this is a standard deviation of sample. If you're going to read this line carefully, this is not the standard deviation of population. It is clearly saying the radio producer measures the duration for the selected song played on the radio station, not repeated workday playlist, and computer sample mean duration to be this with the standard deviation of this. Compared to this one, I just wanted to show you here what was given to me. A 30 business executive found out that on an average they spend 128 minutes each week responding the population standard deviation. They specifically said the population standard deviation of the previous study is 15.2 minutes. So they've taken it from the previous study. That's why we use the z distribution. Now in this one we are using the standard deviation of the sample. So S value is 4.27 minutes. Well, not this value, it is 1.12 minutes, and calculate the margin of error and construct a 95% confidence interval. So I will clearly use the t distribution because neither sigma is given to me nor the question says assume s is equal to sigma. We cannot do that also. So I'm going to move to the t distribution in that scenario. So t alpha over 2 value I'll try and calculate. So 52 is the n value. 52 degree of freedom will become 51, and I'll look into the table for the 95% confidence interval. 95 will be here. So 52, if I go and look into 50, prior value to 51 is 50, and this value is from here, that is this value 2.009. So 2.009 will be the value which I'm going to take. 2.009. All right, now I'll calculate the margin of error, which is equal to t alpha over 2 multiplied by s upon square root of n. So t alpha over 2 is 2.009 multiplied by s value, which is 1.12 and square root of 52. So if I were to do this calculation on my calculator, it will be 2.009 multiplied by 1.12, and that divided by square root of 52. That comes out to be 0.312. That is margin of error. Now I'm going to look into what is the x bar value, that is up to 2 decimal places. So margin of error is 0.31. That is the margin of error. Now I'm going to create an interval x bar minus e less than mean less well, this is greater than, for the mean is greater than this value, and mean is less than x bar plus e, and so this value will come out to be 4.27 4.27 minus 0.31 less than mean, and 4.27 plus 0.31, and you're gonna compile your results. So 4.31 plus 4.27 plus 0.31, which is 4.58, and mean, and here 4.27 minus 0.31, which is 0. In simple words, I can say we are 95% confident that the true population mean will lie between 3.96 and 4.58 for the duration of songs on the station no repeat workday playlist. All right, so hopefully you were able to understand how you're going to solve these questions. So I'll encourage you to do this question on your end. And yeah, that's it for this topic. I'll see you with another video. Till then, goodbye.